Ever wondered why populations rise or shrink over time? With exponential and logarithmic functions, we can uncover the hidden patterns of growth and decay, from booming cities to fading resources. Math isn't just numbers, it's the story of life's changes. In Asia, there is a country called Malaysia. Its population stood at 34.3 million in the year 2021. It was growing slowly, at just 1.15% per year 2021. Families expanded, cities grew. And the numbers on our charts rose gently, year after year. The numbers of national chart moved in a familiar, steady line, pointing upward. We thought we understood this story of growth. It was a story we had seen for decades. It felt safe, it felt normal, but then, something unexpected happens. The COVID-19 pandemic has broken out. A virus, unseen and silent, arrived on our shores. A steady rhythm of growth was broken. A new number appeared. 13% excess mortality. These numbers does not behave like the ones we knew. They did not grow slowly, they exploded. Imagine, if you have a town with 10,000 people and 100 more people are added every year. The growth is linear. It is predictable, but population does not grow in a straight line. It is exponential, but on a very slow and long timeline. It works through multiplication. The formula is P_ERT, where P_ represents starting population, R represents the growth rate, and T represents the time in years. For Malaysia, this growth was gentle, but still exponential. Like a tree adding more leaves each season, slowly but surely. Every year, the base of the population became slightly larger, so the following year's growth was built on a bigger foundation. This compounding effect is the essence of exponential growth. It looks small at first, but over decades, it reshapes entire nations. For example, even a growth rate below 1% can add millions over time. That's why governments track these trends so carefully. Malaysia's steady population growth before COVID seemed predictable. To reflect the pandemic, scientists adjusted the formula shown above, where D represents the death impact from COVID-19. Before calculate the population, let's listed down the information mentioned before. Now, let's calculate TT equals P_ERT1D equals 34.3 times E0.0115 times 5 times 1 to 0.13. And the answer will be 31.6 million. This is the graph based on the calculation. The population without COVID is significantly larger than population with COVID. Instead of expected 36.33 million after 5 years, it is predictable to be dropped to just 31.6 million due to the pandemic. A loss of millions, less cut short by the pandemic if no actions is taken. This is not just math on paper. This is where exponential and logarithms become essential. On a logarithmic scale, the curve becomes a straight line, which is much easier to analyze. Thank you for watching.